I've been working on an electric motor for I think the last 3 years, and I've gotten to a point where I am ready to start prototyping. So this is the rotor section. The rotor section rotates. Let me just pause this. So this is the rotor section. The rotor section rotates, and it happens to have trapezoidal sections of permanent magnets, and they are arranged in alternating order, so north, south, north, south, north, south, all around the circumference of the metallic disc. And then this is a plastic disc that I'm going to temporarily use to test this. This is currently being 3D printed. I have some bearings over here, and then the bearings hold on to the shaft, which is this. And then this is what we call the stator. So the stator is what holds onto the copper windings, and the copper windings help to commutate or rotate the motor, basically, given a couple of signals from a controller. So let me move on to my work desk, my workstation. So I have my 48-volt battery. So this came from an e-bike battery. This is the stator that you were seeing. So this is 3D printed. Ideally, it should be made out of some metallic material that I currently do not have and is quite expensive to prototype with. So that's why I ended up just going with 3D printed material. So you can see my wires are already wound around the different sections, the different slots and sections. And then this is the shaft that I'm going to be using, so it slides on quite well. I already had printed this disc, but I need to redo it, and the reason for that, I wasn't paying attention when I was doing this disc. So unfortunately, this metallic disc that holds onto the magnets, and these are the trapezoidal sections of the magnets that I was speaking about, does not fit into this. We're currently at 2 hours and 34 minutes, but let's move on. So this weighs 704 grams, and let me turn on the Tesla meter. So this is used to measure how strong a magnet is. So we are reading something like 400 Tesla. This is north, this is south, north, south, and it goes all around according to following the circumference of the disc. And you can see the magnets are actually active using this magnet paper. And this is what it looks like from top section. And the next thing I need to do is basically connect my controller to the computer and configure it for this motor. And then we are going to see an electric motor. This, I believe this is the first of its kind in the country, probably in Africa. If you are interested in the kind of work that I'm doing, so these electric motors are actually meant to be used as traction motors. So traction motors are the ones that are used in electric vehicles. This model that I'm currently testing is currently simulated for up to around 60 kilowatts. And then I have other models that are simulated up to around 200 kilowatts. So it really depends on what you need. And we are almost done. Still going, currently at 95%. It's been 4 hours. So up next, I'm gonna bring my computer over just to start the testing. The disc just finished printing, and I'm going to proceed with the installation. Now I need 2 hands for this, so I'm gonna do this off camera, and then I'll do the setup. As you can see, the controller is already set up, so it's connected to power, the main power. The stator is already connected to the controller. Now all I have to do is assemble this, and then I have my hex screws ready to assemble everything, and then I'll do the first run. I've got my setup done, and I'm going to be using the arrow key to control the speed. So it's a bit jerky at the beginning, and that's because it doesn't have a position sensor, but Something might have broken at some point. I've already done the initial test, so we're looking at 1600 RPM, which I don't think is that bad, and the motor is actually running quite hot. I definitely think there is a lot of resistance, so we're looking at what, around 52 degrees, 54 degrees Celsius. There's a lot of resistance in the wires because of the fact that the motor doesn't have position sensors. The position sensors basically tell the controller, which is this, where to send the power depending on the position, the rotational position of the rotor. So the fact that I don't have positional sensors is what's creating that problem of overheating. It's not too hot to the touch, definitely. I could definitely do a very noisy run, but it's okay. I think I've got my proof of concept down. So there's a lot more to do when it comes to building this electric motor, and I'm definitely going to be working on improving some of the things that I've noticed about it. So this is not the complete version of the whole thing. At Huskberry Engineering, we are solely focused on designing drivetrains around the axial flux motor topology. And a drivetrain does not just include the electric motor as you have seen it run. It also includes things like gearing systems and differentials. So if you need one of these, we can hook you up. And if you need consulting about battery packs, we can also hook you up. If you would like us to take you through the journey of building an electric vehicle, please contact us via email, that is engineering@huskberry.com, and we'll be sure to help you out with all the integrations that you may require for your electric vehicle build. But that's it. This is Huskberry Engineering. This is what we do. We build electric drivetrains for traction purposes.